We've spent an entire domain learning how to install, configure, and manage operating systems. We've mastered the machine, but now we have to learn how to protect it. Welcome to Domain 2, Security. This is your rapid-fire review of Objective 2.1. Security is divided into two worlds, logical and physical. Let's start with logical security, the rules governing the digital realm. The foundation is Identity and Access Management, or IAM. Think of it as the HR department for digital identities. It manages the entire life cycle of who gets access to what. It all starts with directory services, like Active Directory, which is the central phone book and master key registry for the entire network. To make life easier, we use Single Sign-On, or SSO, which is like a master key card that lets you authenticate once to access multiple applications. For web apps, this is often handled by SAML, an open standard that acts like a digital valet, confirming your identity with a trusted source before granting you access. Now, who gets what power? The principle of least privilege is king. A user or app should only have the minimum permissions necessary to do their job. For high-level accounts, we use Privileged Access Management, or PAM, which locks super-user accounts in a secure vault. A key PAM strategy is just-in-time access, which grants temporary expiring admin rights, preventing an attacker from gaining permanent control. This all fits into the Zero Trust model, a security architecture where nothing is trusted by default. It's like having a security checkpoint at every single door inside the building, not just the front entrance. We enforce these rules with access control lists on routers and within the OS itself. To protect our data and devices, we use Data Loss Prevention, or DLP, a system that stops sensitive data, like credit card numbers, from leaving the network. For phones and tablets, we use Mobile Device Management, or MDM, a central console that can enforce security policies and, critically, remotely wipe company data from a personal device if an employee leaves. To prove we are who we say we are, we use multi-factor authentication, or MFA, which requires more than just a password. The factors are something you know, a password, something you have, your phone, something you are, a biometric, or somewhere you are, your location. Common methods include an authenticator app that generates a time-based one-time password, or TOTP, a physical hardware token, or a code sent via SMS or voice call. Though be warned, SMS and voice are vulnerable to SIM swapping attacks. Next, physical security, protecting the actual hardware and facilities. This starts at the perimeter with fences and bollards to stop vehicles. To enter, you might pass through an access control vestibule or a man trap, which ensures only one person enters after being verified by a security guard. Lighting is a critical, simple deterrent. Magnetometers detect metal, and alarm systems use motion sensors to detect intruders. For access, we've moved beyond simple keys. Now we use key fobs, smart cards, or even a mobile digital key on our phones. To protect servers, we use equipment locks on the server racks themselves. The strongest proof of identity is biometrics. This isn't a photo, it's a digital map of a unique physical trait. A retina scanner, which reads the capillaries in your eye, is one of the most accurate. Fingerprint scanners and facial recognition technology, which creates a 3D map of your face, are also extremely secure. PAM print and voice recognition exist, but are generally considered less secure. To recap, logical security is about access rights. Key concepts are IAM, SSO, SAML, and the principle of least privilege. The modern approach is the Zero Trust model. MFA strengthens logins by requiring multiple factors, like something you have, an app generating a TOTP, and something you are, a biometric. Physical security protects facilities. It starts with perimeter controls like fences and bollards and uses layered access like vestibules and security guards. Modern physical access relies on tokens like smart cards and key fobs, with biometrics like retina scans and FRT providing the highest level of authentication.